Let's take a look at another kind of special quadrilateral, the trapezoid. Now, by definition, a trapezoid is a quadrilateral that has exactly one pair of parallel sides. So if we look down here, here's an example of a trapezoid, and you can see that segment AB and segment DC would be the parallel sides. So let's go ahead and mark those as parallel. AB is parallel to DC. Now those parallel sides are called the bases, right? So this guy here, that is called a base, and this guy here, that is called a base. The other sides are called the legs. So segment AD would be a leg, and segment BC would be a leg. Each pair of angles with vertices at the endpoints of a base are called base angles. So in other words, we have two pairs of base angles here in this picture. You can see that at the base DC, you have an angle D here and an angle C right here. Those are called base angles. Base angles there and there. Also, though, you have another base, of course, up here at AB. So you'd have this pair of base angles right here, angle A and angle B. So those are the different parts of any kind of trapezoid. Now, if the legs of a trapezoid are congruent, so if AD was congruent to BC in our picture here, then we call that an isosceles trapezoid. It doesn't happen on every trapezoid, just on some of them. But if the base angles of if we do have an isosceles trapezoid, right, then the base angles will always be congruent. So the base angles of an isosceles trapezoid are congruent. So in other words, in this picture here, if ABCD is a trapezoid, and if it has two sides that are parallel, and AD is congruent to BC, then that would mean that angle D is congruent to angle C, and angle A is congruent to angle B. One other term that we need to know about trapezoids, it's called the median of a trapezoid. And the median of a trapezoid is a segment that joins the two midpoints of the legs. And we've used this word median before when we're talking about a triangle. I just want to kind of make sure you understand that this is different than the median of a triangle. Same name for two different things. So if we look down here at this picture, MN would be a median if segment EM and segment HM were congruent, or in other words, if M was the midpoint of this leg, and also if FN was congruent to GN, or that N was the midpoint of this leg. That would make this guy here, that would make this the median of this trapezoid. Now, according to theorem 5-19, the median of a trapezoid will be parallel to the bases. So of course our bases are parallel to each other, and then the median would be parallel to both of those things. And it would have a length equal to the average of the length of the bases. So in other words, if this is a trapezoid, and if EM is congruent to MH, and FN is congruent to NG, in other words, if this is the median, then EF is parallel to MN, which is parallel to HG, and the length of MN will be 1/2 of the total of EF plus HG, because of course that's how we take an average, right? I'll rewrite this. I know this is a little bit small here, probably on your screen, so let me just rewrite that over here. MN, according to theorem 5-19, will be the average of EF and HG's length. Well, to find an average, we add the things together and divide by how many we have. So in other words, we could add EF plus HG and then divide by 2. But maybe the better way to write that is the way I wrote it over there. We just take it 1/2 of EF plus HG and write it that way. So let's look at an example here where we can put some of this, put some of these things to use here. Sorry, I got a stray mark right there. Let me get rid of that. Let's put some of these ideas to use. If the measure of angle D in this picture is 115, And if EF is a median, well, first of all, let me back up a little bit. Our instructions say that EF is a median. So let me just remind myself what that means. It means that these two will be congruent to each other, and those two would be congruent to each other. And since this is a trapezoid, I know that all of these are parallel to each other. Now, if the measure of angle D is 115 degrees, then what's the measure of angle A? Well, if these lines are parallel, and this would be like a transversal, that would mean that angle D and angle A would be same side interior angles. And we know that when the lines are parallel, those same side interior angles need to be supplementary. So the measure of angle A would be equal to 180 minus 115, which is 65. So angle A is 65 degrees. If segment DA was congruent to segment CB, well, that would make this an isosceles trapezoid, right? If this was true right here, that means this is an isosceles trapezoid. If angle C is 107, so if I put a 107 right here, then what's the measure of angle DEF right here? Well, if this is 107, then that would mean that this would be 107. And that these two, again, because these lines are parallel, these two would need to add up to 180. So that angle DEF would be equal to 180 minus 107, which is 73 degrees. Come down here to part C. If AB is equal to 25, and if DC is equal to 13, then how long is EF? Well, we learned on the previous slide, we learned that that median will have a length that's equal to 1/2 of the two bases added together. So that would be 1/2 of 38. And half of 38 is 19. Next up, we got a problem that says AE is 11, FB is 8, then what's AD and what's BC? Well, again, if we know that this is the median, that means E is the midpoint. So if this part's 11, this part's 11, and that would mean AD would be 22. BC, well, we got 8, and then we'd have another 8 there, and BC would be 16. Next up, we got AB equals 29. So let me get rid of that. Now I'll put a 29 there. EF is 24. What's BC going to be? So let me get rid of that 13. Well, 24 needs to be the average between AB and DC. Now there's a couple ways you could do this. You could do it a mathematic, kind of an algebraic way. You could say that 24 is equal to 1/2 of x plus 29, using x for this unknown side length. And you could solve it that way. Or you can kind of think intuitively. If this is the average between these two, and it's, well, and we got to kind of realize that this picture might not be drawn maybe to scale, but in any case, if this is 4 units shorter than this side, then that means it needs to be it's 5 units shorter than this side. It needs to be 5 units longer than this side. So what's 24 minus 5? It's 19. And if you work this out, you can see that that should work out as well. You would double this side to get rid of the 1/2. So you'd have 48 equals x plus 29. And then you'd subtract 29 from both sides. And you get 19 for the value of x. Lastly, we got AB is equal to 7y plus 6. 7y plus 6. And EF is 5y minus 3, and DC is y minus 5. How can we set up this one to solve? Well, we use that same idea, that EF, which is 5y minus 3, will be equal to half of DC, which is y minus 5, let me get rid of that parentheses, plus AB, which is 7y plus 6. Now I got to clean this up a little. I got to combine my like terms within this parentheses. So let me rewrite this stuff. And now I have a y plus a 7y, which is an 8y, a negative 5 plus a 6, which is a plus 1. Now I want to get rid of this 1/2 next. The way I'm going to do that is I'm going to multiply both sides times 2. That's going to be 10y minus 6 equals 8y plus 1. Now I'm going to subtract 8y from both sides. 2y minus 6 equals 1. Add 6 to both sides. 2y equals 7. which would mean that y would equal 7 over 2 or 3.5.